There is a hand holding your phone right now, and it is not the one you would write with. You did not decide that. You have never decided that. Somewhere underneath the part of you that makes decisions, something already sorted your two hands into a good one and a spare one, and it did it so long ago that you have no memory of it happening. 9 out of every 10 people watching this sorted them the same way you did. You already have a guess about why. Almost everybody has the same one. Hold on to it. Because in May of 2026, somebody finally tested that guess properly against 2,025 individuals across 41 different species, and it finished near the bottom of the list. Start with how strange the thing being explained actually is. 90% is true in every country. It is true in every culture anybody has ever gone and counted, on every continent, going back as far as we can dig. There has never been a single human population anywhere on Earth that was mostly left-handed. Not one, not ever, not once in the entire record, and no other animal does this. Chimpanzees have favorite hands, and so do gorillas, and so does almost everything else with fingers. But ask 100 chimps and you get roughly 50 of each, which is what a coin flip looks like. We are the only ones who all agreed. So where did that come from? Start with when you got yours, because it is earlier than you think. Before you were born, you sucked your thumb. Almost everybody does, from about 15 weeks onward, and if somebody had pointed an ultrasound at you at the time, they would have seen which thumb you chose. About 9 in 10 fetuses choose the right one, about 1 in 10 choose the left. If those numbers sound familiar, that is the point. Now here is the part that should bother you slightly. A team went back and found 75 people whose thumbs they had watched on a screen before those people were born. They tracked them down 10 and 12 years later as children who could hold a pencil, and they checked. 60 of those fetuses had sucked the right thumb, and all 60 grew up right-handed. Not most of them, and not a strong tendency. 60 out of 60. The left thumb ones were messier, and that difference matters, and we will come back to it. But the right-handed result is about as clean as this kind of research ever gets. The hand you are using to hold your phone was picked before you had lungs that worked, before you had a name, before anybody had seen your face. So it is not a habit, and it is not something a teacher installed. It was already running while you were upside down in the dark. You can feel the thing itself if you want to, right now, and it takes about 4 seconds. Sign your name in the air with your good hand. Then sign it with the other one. Pay attention to what is actually different because it is not what people say it is. Your spare hand is not weak. It carries shopping. It opens doors. It holds a glass without dropping it. And the muscles in it are close enough to the same. That is not where the difference lives. The difference is that you had to think about it. With your good hand, your name arrives finished. You do not plan the letters, you do not decide where the pen turns, and you could do it while talking to somebody about something else entirely. With the other hand, you are suddenly supervising. You are aware of the corners. You are choosing, mid-letter, what happens next. That gap between the hand that does it and the hand that has to be told is the whole subject of this video. One side of you got given the job permanently, and the wiring for it got built out over a lifetime, and the other side never did. Now the question is who assigned it and when, which sounds like it must be genetic, and this is where it gets awkward, because it is not that either, not simply. Take identical twins. Same DNA, same womb, same everything the word inherited is supposed to cover. In roughly 1 pair in 5, they do not match. One writes with the right, the other with the left, or with either. Whatever is choosing the hand is not just reading the genes because 2 people with the same genes get different answers about 1 time in 5. You can see the same fuzziness in your own family. 2 right-handed parents have about a 9% chance of a left-handed child, which is barely different from a stranger's odds. 1 left-handed parent takes it to around 19. 2 left-handed parents take it to about 26. Look at that top number for a second. Both your parents left-handed, every genetic advantage stacked, and it is still roughly 3 to 1 that the child comes out right-handed anyway. That is not how a gene for a trait behaves. That is a thumb on a scale. Something is loading the dice toward the right in every family on Earth, including the families actively pulling the other way, and the loading is happening before birth. Something old is doing this, and something old enough to reach into a womb is much older than any of us. Go back to the chimps because the comparison is the whole mystery and it is easy to skim past. Almost every animal that handles things has a preferred side. Cats have a preferred paw. Parrots have a preferred foot. A chimpanzee will fish termites out of a mound with the same hand for its entire life and never switch. Individual preference is completely ordinary. What is not ordinary is agreeing. A chimpanzee troop is split, half led with the left, half with the right, and neither half is winning. Every individual is committed and the population is undecided, and that is the normal state of affairs for a species with hands. Then there is us. 90% one direction everywhere for as far back as we can measure. So the question was never why you have a better hand, cats have a better paw. The question is why an entire species picked the same one, and that is a much stranger thing to explain because there is nothing about the right side of a body that is better than the left. Your hands are mirror images. Your arms are the same length. Nothing about the meat of you prefers that side. Something else was choosing. The oldest evidence we have of that choice is a jaw. It came out of Olduvai Gorge in Tanzania. It is catalogued as OH65, and it belonged to a Homo habilis who died about 1.8 million years ago. Not a human. Something on the way to one with a brain about half the size of yours. You cannot see a hand in a skeleton. Hands are small bones, and small bones scatter and rot and are almost never there when you dig. So for a long time, there was no way to ask a fossil which side it favored. Keep that in one sentence because this whole story comes back to it. You cannot see a hand in a skeleton. You can only see what it did. What OH65 did is scratched across the front of its own teeth. Here is how those marks get there, and it is worth slowing down for, because once you have seen it, you cannot unsee it. They had no third hand and no table. When you are cutting something tough, something like a strip of hide or a length of sinew or a piece of meat that will not tear, you need 3 points of contact. One to hold, one to pull, one to cut. So they used their mouth as the third one. You put one end of the hide between your front teeth and you bite down. You take hold of the other end and you pull it tight. And with your free hand, you bring a stone flake up to the taut part right at your lips and you cut downward and away from your face. Do that 10,000 times over a lifetime and the flake is going to miss sometimes. It slips off the hide and drags across the enamel of your front teeth, and it leaves a scratch, and enamel does not heal. That scratch is still there when you die, and it is still there 1.8 million years later. And the scratches are diagonal. That is the whole trick. If the stone is in your right hand, you are cutting down and across to the left, and every scratch slants the same way. Put the stone in the left hand, and every scratch slants the other way. The marks are a recording of which hand was moving, made entirely by accident, by somebody who had no idea they were writing anything down. The scratches on OH65 slant down from the left to the right. Right-handed. 1.8 million years ago, most of the way back to the beginning of our genus, somebody was already leading with the same hand you are. And once researchers knew what to look for, they went and looked at everybody. The Neanderthals are the best sample because they used their mouths as a workbench constantly, and their teeth are thick, and thick teeth survive. So there are a lot of scratched Neanderthal front teeth sitting in museum drawers, and somebody sat down and counted the direction on every one of them. 27 right-handed, 2 left-handed. That is 93% to 7%, which is, within the error you would expect from a sample that size, the exact split walking around your town today. A different species 100,000 years ago in a different climate, in a world with no writing and no schools and nobody to copy, and they landed on the same ratio we did. The stone tools say it too, and they say it independently. When you nap a flake off a core, you work around it in a direction, and the direction differs depending on which hand swings the hammerstone. You can pick up a tool nobody has touched for 60,000 years and tell which hand shaped it. At least 85% of the Neanderthal tools from the German sites were made by right-handers. And when people started putting their hands on walls, they told us a third time. In Argentina, there is a cave called Cueva de las Manos, the Cave of the Hands, and the wall is covered in hundreds of stenciled hands. They made them by pressing a hand flat against the rock and blowing pigment through a hollow bone. So what survives is the negative, the clean shape of a hand inside a cloud of color. Almost all of them are left hands. 829 left hands against 31 right. Which is not a fact about their left hands at all. It is a fact about their right ones. You press your spare hand to the wall and you hold the pipe with your good one, because the pipe is the part that needs control. Hundreds of people across generations in Argentina and Indonesia and across Europe, all putting up the same hand and all keeping the same one back. You cannot see a hand in a skeleton, but you can see the wall it touched and the tooth it slipped against and the stone it shaped. There is one more piece of evidence, and it closes off the objection everybody raises, so it is worth being clear about it. The easy explanation for all of this is culture. Somebody will always say that right-handedness was taught, that left-handedness was punished, that societies beat it out of children. And that last part is completely true. It happened for centuries within living memory, and it was cruel. But it cannot be the cause, for two reasons. The first is arithmetic. If culture created the bias, the ratio would move. Cultures that never met, on continents that did not know each other existed, separated by tens of thousands of years, would not all arrive at 90%. They would arrive at different numbers, the way they arrived at different languages and different gods. The number does not move. The second reason is a child. Among the scratched teeth, there is a set that belonged to somebody between 6 and 8 years old. Same diagonal marks, same direction, already committed. 6 years old, in a world with no schools, no writing, no desks built for one hand, and no adult standing over them correcting it. The pattern is there before anything exists that could have installed it. And then there is the fetus, and the 60 out of 60. Nobody teaches a fetus anything. So, not taught, not recent, not simply inherited, and locked in before birth. Something structural is doing it. For most of the last century, everybody had the same answer, and it is almost certainly the one you are still holding. Tools. The story goes like this, and it is a good story. We are the species that makes things. Making things is fiddly work. Fiddly work needs one hand to lead and one hand to steady. The leading hand has to get very good, and a hand only gets very good with practice. Split the practice between two hands and you get two mediocre hands. Commit to one and you get a specialist. So we committed, the brain built the specialist on one side, and the whole species converged because the tools we handed down were shaped for it. It fits everything. It fits the flakes and the scratched teeth. It fits the fact that the patch of your brain handling tool use sits right beside the patch handling speech. It has been the standard answer in textbooks and documentaries for decades, and if you have ever heard an explanation for any of this, that is the one you heard. The problem was that nobody had ever actually tested it. It was a story that fit. A story that fits is not the same thing as an answer. In May of 2026, a team at Oxford and Reading tested it. Here is what they did because the method is the reason the result counts. They gathered handedness data on 2,025 individual animals across 41 species of monkeys and apes. Then they took every competing explanation anybody had ever offered, and instead of arguing about them, they ran all of them against the data at once. Tool use, diet, habitat, body mass, social structure, brain size, and how the animal moves. And they did it with a model that corrects for something people get wrong constantly, which is that species are not independent of one another. Two species might share a dominant hand because it solves the same problem, or they might share it for the boring reason that they both inherited it from the same grandmother. If you do not account for that, family resemblance walks into your results wearing a lab coat and pretends to be a discovery. Then they looked at which explanations survived. Tool use did not. Sit with that because it is the whole video. The answer everybody has, the one in the textbooks, the one you were holding 4 minutes ago, went into the model alongside 6 alternatives and came out near the bottom. Diet did not predict handedness either. Neither did habitat or body mass or how complicated the animal's social life was. Two things predicted it: whether the animal walks on 2 legs and how big its brain got. We spent a century looking at the hands. The answer was in the feet. And once you have heard it, the logic is almost annoying in how simple it is. Standing up did not give us a better hand. It gave us a spare one. An animal on 4 limbs is spending all 4 on the ground. Its front limbs are landing gear, and landing gear has to match because a body that pushes harder on one side than the other walks in a circle. There is no room to specialize a limb you are standing on. Stand up, and 2 of those limbs go idle. They are not load-bearing anymore. They are not required to be identical anymore. For the first time, there is no cost to making them different from each other. And there is an obvious benefit because two hands doing the same job is a waste of one hand. But a spare limb is not a dominant limb. Something still has to do the assigning, and that is the second half of the result, the one about brain size. A bigger brain is not just a more powerful brain, it is a more expensive one to coordinate. Every task you run across both halves has to be agreed between them, and agreement takes time and wiring, and both of those are costly. The bigger the brain gets, the more it pays to stop duplicating and start dividing. Give a job to one side permanently and let the other side do something else, which is where that objection about language belongs, and it is the sharpest one anybody makes. In about 99% of right-handers, language sits almost entirely in the left hemisphere, the same side that drives the right hand. People have read that for a century as language explaining handedness or handedness explaining language. The result reframes both. Neither one caused the other. They are two symptoms of the same thing, a brain that got large enough that specializing by side beat doing everything twice. Speech went to one side for the same reason fine motor control did. The hand and the voice ended up as neighbors because the brain was sorting jobs, not because either one was in charge. So tools did not create the dominant hand. The dominant hand was already forming, and it is what made us good at tools. We had the sequence backwards the entire time. And there is a way to check all of this that does not involve humans at all, which is the part I like most because it is a natural experiment nobody had to set up. Go to Australia. In 2015, a team went and watched 4 species of macropod in the wild the family kangaroos and wallabies belong to. They watched them groom and feed and handle things, thousands of observations, and they recorded which forelimb each animal used. Red kangaroos, a clear population level preference. Eastern gray kangaroos, the same. Red-necked wallabies, a preference as well. Split by job, one limb for fine work and the other for anything needing force. The 4th species showed nothing at all. No preference in any task in either direction. The 4th species was Goodfellow's tree kangaroo, and what makes a tree kangaroo different from the other 3 is not its diet, or its brain, or its social life, or its tools, because it does not have any. It is that a tree kangaroo lives in trees and moves on 4 limbs. Same family, same continent. The ones that stand up have a dominant limb, the one that stayed on 4 does not. That is as close to a controlled experiment as evolution is ever going to hand you, and it was standing in Australia the entire time we were staring at stone tools. And there is one detail in there that finishes the argument off. The kangaroos are left-handed. Not some of them. As a population, the red and eastern gray kangaroos lead with the left forelimb, about as strongly as we lead with the right. They picked a side, they all picked the same side, and it is the other one, which tells you what the rule actually is. Standing up does not make a body right-handed. Standing up makes a body pick a side, and then the side it picked gets locked in and passed down, and it stops mattering which one it was. We got right. They got left. A coin came down a very long time ago, and everything since has been the consequence. That is the honest shape of the answer, and it is better said plainly than dressed up. We now have a real explanation for why our species committed to one hand. We do not have one for why it was that hand. The coin landing the way it did is still, as far as anybody can prove, luck that got inherited, which leaves the 1 in 10. If right-handedness is what a standing, big-brained body drifts toward, left-handers should have been squeezed out long ago. 10% is too large to be a mistake and too stubborn to be noise. It has held at roughly 1 in 10 for at least 500,000 years. Through every population ever counted, through centuries of people actively trying to stamp it out. Something is holding it there, and the study that answered the big question does not answer this one. The authors say so themselves. Why left-handedness persists at all is listed in their own paper as unfinished business. So if you are one of the 10%, the honest position is that you are the part of this nobody has explained yet. Every human population ever counted has kept a minority who reached the other way, has kept it at almost exactly the same size, and has kept it through everything that was done to make it stop. The rest of us have a story now. You are still the open question. Which brings it back to the hand on your phone. It was never a preference, and it was never a decision. It was set before you were born by something already running 1.8 million years ago in a jaw in Tanzania, and running for the same reason a kangaroo has a favorite arm. because a body that stopped walking on its hands was left holding two limbs it no longer needed for the ground, and something had to be done with them. Every generation since has left the evidence the same accidental way: a slip of a stone flake across the enamel of the front teeth, a tool napped in one direction and not the other, a hand pressed flat to a cave wall in Argentina while the other one did the work. You cannot see a hand in a skeleton. You can only see what it did. A very long time from now, somebody looking at whatever is left of you will not find your hands either. They will find the things you touched worn down slightly more on one side.